Thank you everyone for joining for this sneak peek into the technology radar. Before I get started, I'll just do a few introductions. So I'm Rachel Laycock. I'm the Global Chief Technology Officer for Thoughtworks. I'll hand over to my colleague Sophia. Tanya?
Hi, yes, I'm Tanya. I'm a principal technologist with Thoughtworks. I'm based in New York.
And James?
Hey folks, much the same as Tonya. I'm a senior technologist at Thoughtworks. I'm based out of London and very happy to be here with everyone today.
Yeah, so welcome. So I will be moderating today, and Tanya and James will be giving us a lowdown on some of the key themes and blips, or their favorites anyway, coming into the next edition of the radar, which will be released on October 23rd. So for those that are not aware of what the radar is, it is Thoughtworks' opinionated view on what's happening in the software industry over the last 6 months. So we mine input from all our development teams across the world, around 10,000 people, hundreds of clients and teams, and ask them, what's useful, what's not useful, what are you liking, what are you not liking, and then we spend a week arguing about it, and then provide that summary back to the world. Initially, it was done as an internal exercise to keep track of what was going on, but a lot of our clients found the data useful, so we started publishing it, and that was over 10 years ago now. So just to give you a little bit of a lowdown on how the radar works, obviously it's leveraging the radar metaphor as things come in from the outside and into the center. The things that are in adopt means that we're kind of saying if it makes sense in your project, your product, use it by default. Things in trial means that we've at least the things in adopt we've probably used in anger. So it's good to go in production. The things in trial, we've got some production experience and we think it's very promising, but it's not necessarily the default. In assess is where it gets really busy because that's all the things that are up and coming, that we're testing out, we're getting some good use out of. We think it's worth saying something about. And then hold, which is always the most controversial one, is where it's a little bit more of proceed with caution. We're seeing some challenges with this, and we'd like people to be aware of that. Also, each radar, we usually identify like 3 to 5 themes. And that's really based on as I said, we spend about a week arguing and discussing and coming up with the output for this. That's usually the main discussion topics that come up. Either blips that make it or don't make it onto the radar. What are some of the key themes that we're seeing occurring over the last 6 months? So without further ado, we will dive in. I will just ask that you please put your questions into the Q&A. It's really hard to keep track of them in the chat. And I will try and keep an eye on them and weave them in as we go. A worst case, we'll do the questions at the end. But we'll talk about a couple of themes first that are coming up on this radar, and then we'll dive into some of the blips. So first of all, I will hand over to my colleague James, who's going to talk about WASM, which might seem like a weird theme because it's a pretty low level thing. But yeah, James, tell us, why is WASM a theme this time?
Yeah, thanks, Rachel. It is, as you say, quite a low-level thing in WebAssembly. And it's specifically this gradual rise of WebAssembly and associated tooling around it that we wanted to call out this time as a theme. There are a number of tools on the radar this time around, which I won't really talk about. You'll have to wait for the full radar to come out. But we wanted to call out really that there seems to be this gradual movement towards more and more adoption of WebAssembly, both client side and also server side. So WebAssembly, I think, was created back in about 2017. We first featured it on the radar, WebAssembly, in May 2018, and then we had it the same year. Then we featured it again March 22, and then last year we had a number of items with things like WASM time. I think on the last edition, I think we had WASM time there and a few others. And then this time around, we seem to spend quite a lot of time during the meetings actually talking about WebAssembly related tooling, as I say, whether that's server or browser based. So, I mean, what is WebAssembly? As I sort of mentioned, it's quite a low-level thing. Basically, it's a binary format, instruction format for a virtual machine, which can run within the existing JavaScript virtual machines on and all the major browsers now. So it's supported by Chrome, Firefox, Safari, and Edge. The interesting thing about it is that you can essentially compile other programming languages to that stack-based assembly language. So things like Rust, C, C++, Kotlin is now supported. Java's coming soon, and it's also an LLVM assembly target. So compile target. So what you can do is write in other programming languages that maybe you're familiar with, and then use the browser as a target to deploy those languages. I've used it personally myself using the Blazor framework. So I wrote some simulation code in C++, in C# a little while ago. And then it was just super easy to use, use WebAssembly as the deployment target. And suddenly I have this C# simulation running in the browser. So super interesting. It's high performance. It runs pretty close to natively. You get the flexibility of different languages. But I think the key thing now is we're seeing a lot of WebAssembly beyond the browser, which is what it was originally targeting. So we're seeing a lot of server-side WebAssembly using the WebAssembly system interface. It's a W3 standard, and there's a ton of implementations out there, a ton of runtimes. So things like WASM time, there's WAS0, there's a whole bunch of others out there. And there's frameworks starting to be built up now. There's one called Spin, which is a microservices framework. I had to say microservices being me. And the interesting thing is they're following the same sort of security model that you get in the browser. So it's very hard to jailbreak. So why now? Why is this cool? And why do we have this as a theme? What's the cool thing about it? Well, I think for me, the interesting thing, and this is a personal opinion, you've seen this evolution of containerization and the idea that we should write once and run anyway, going back to the JVM. But then when we look at things like unikernels, the idea that we're going to compile really, really simple single-purpose operating systems and compile our applications into those and have them run, or then the rise of Docker and containerization and containers running on Kubernetes. What we're seeing now is server-side WASM runtimes running in Kubernetes. So there's a tool which we're featuring, which is called Spin Cube. And Spin Cube is essentially a set of things like operators, some shims to allow WebAssembly to run inside Kubernetes. So this is sort of ongoing evolution, where I used to think unikernels were the cool thing, and then everyone jumped on Docker as the cool thing. Maybe now server-side WebAssembly in Kubernetes is the cool thing. And that's why we have the gradual rise of WASM featuring this time around.
Well, there you go. You answered the question I was going to ask you, is like, why now? What's happening now? So that was the first theme. The second one is, it was probably a surprise to nobody, is the Cambrian explosion of generative AI tools. It's almost it's a good job it wasn't a drinking game during the session talking about any AI tools. Otherwise, the whole group would have been quite drunk. But I will hand over to Tanya now, who will give us a bit of an insight into why this was a theme and what were some of the tools that were popping up and made us think about this.
Yeah, totally. So some themes capture discussions around blips that don't all necessarily make it to the radar. But in this case, again, to nobody's surprise, there's a lot on the radar around Gen AI. We actually kind of counted, it's about 38% of the upcoming radar has blips related to Gen AI. But so what about this theme? Well, obviously, there's something to do with the volume of the blips that actually make it to the radar. But what we are seeing here, what we are seeing more so, this volume as compared to the previous volumes, is explosion of tools around models. So it's around kind of building systems and building reliable systems around these Gen AI models. So really about that path to production. In the past volumes, we talked a little bit more about, oh, there's this new model coming out. Oh, there's that other model, and this is how they are different. But this time, less of that and more around guardrails, right? How do we put policies around what conversations we want to allow, what sort of responses we want the models to generate in our sort of RAG pipeline. We talked quite a lot about evals? How do we evaluate the performance of a system that we are building with LLMs? We talk a lot about observability. How do we do some tracing around, how the prompt template gets turned into actual prompts and that whole thing. We talked also about observability as how it relates to cost as well, how it relates to performance. So a lot of this sort of aspect. And we even talked about prompt compression, right? So a lot of these things that really are around building systems with LLMs or then the models itself. That's the main thing that we are seeing in this volume. There's also quite a bit about, another interesting thing I think is vector databases. So we still have quite a few conversations around vector databases. Qdrant and Vespa are some of the ones there that you're going to see in this upcoming radar. But more and more our discussions are also around how vector databases are not the end-all be-all for the R in RAG, right? So the R in RAG is information retrieval in the general sense, where vector databases is a part of it, but doesn't have to be the only solution. So we discussed how knowledge graphs can be the R, and I think James has something to say about this as well later. We also talked about hybrid search. So to this end also, we did a rewrite or a refresh write-up of our RAG blip to capture the nuance around how we may do information retrieval in this. Yeah, so that's broadly the kind of pattern that we are seeing. Yeah, and we do actually have a couple of blips coming up. They are still related to this theme, so I'm gonna call it here for now.
Yeah, it's interesting. There's a lot happening both on the side of building generative AI into products, as well as leveraging Gen AI to build products. And I think we're all very familiar and have been talking probably most of this year about the challenge of getting, a proof of concept. So when you build Gen AI into a product, into production, and all the illities and all the concerns that you have to look at. And even recently, I read an article from Goldman Sachs that was actually fairly critical of generative AI in general, but made a note saying, except for, in building software, where we're seeing, that uptick, because although there's a lot of concerns around, the security and end-to-end software like tool chain, it's less of a concern than once a product is kind of in production. But that brings me to the first of the blips that we want to talk about. And this is kind of a bit of a favorite of mine, because since at least for the last 6 to 12 months, everyone is talking about agents. And, being a skeptic, I'm always like, do you just mean a chatbot, or is it a real agent? And is it an agent that talks to another agent? And I think there's a lot of really interesting stuff happening over in this space. So I will hand over to James, who's going to give us a bit of a lowdown on what he thinks is going on with LLM-powered autonomous agents and whether they're really autonomous at all.
I'll do my best, Rachel. Thank you. Yeah, I mean it's tricky, right? Because this is still absolutely open area of research. There's just a ton of papers arriving on the archive and on the ACM at the moment around the idea of agents and what even are agents anyway. Agents and agent-based systems are not a new thing. They've been going back decades and decades and decades to agent-based models and how you can use agent-based models as a form of machine learning and to use them to write simulations. So obviously this has been adopted now or brought into the world of generative AI as another, I guess, one of these evolving architectural styles. And I think that's going back to the theme about the Cambrian Explosion of Gen AI tooling. I think that's one of the things we're seeing is these new evolving architectures. It's not just about the model. It's not just about the API to call the model. It's about all the things around the scaffolding that we're having to build around these tools and around the models in order to make this stuff work. LLM-powered autonomous agents being one particular example. So it first appeared for us in Assess back in September 2023. We re-blipped it again the last issue, and it's going to appear this time because things are moving so fast. What are LLM-powered autonomous agents, and how do they differ from, I guess, traditional agents? Well, traditional agent-based models do tend to have things like finite state machines in them, and they do communicate via either, they're very similar to communicating sequential processes and things. But LLM-powered autonomous agents are slightly different in as much as they use the model as a backing to be able to choose what to do next, given a certain set of circumstances. They come in a variety of forms. If you look at different definitions, that I don't think there is really a single definition of this yet. I mean, NVIDIA talks about different types of agent, whether they're single agent or multi-agent models, or even multi-agent, multimodal agent models. So, within the NVIDIA sort of definition, what makes them different is you don't just have a process itself, the agent, but you also have memory associated with that. So it remembers previous prompts and previous inputs in the previous context. Also has things like access to external tooling. We'll come on to that a bit later. So things like external functions and API calls. But also, and typically, certainly in single agent, with single agents, they have often a planning module which allows them to do sort of more complicated tasks and do planning around sort of things like using reactive reasoning about what to do next. So it can break problems up into smaller bits and then reason about how to go through and solve the smaller bits. But then you also have you have that as one type of agent. Then you have the multi-agent models, and you think about multi-agents in terms of some of the tooling out there from, for example, Microsoft AutoGen would be an example of a multi-agent model. You've got things like Crew AI, which are also very popular in terms of multi-agent models. And yeah, it's essentially providing the infrastructure, these new architectural styles around how to coordinate these autonomous agents, being able to communicate amongst themselves to solve more complicated tasks than a single agent could potentially do on its own, or a single API call could do on its own. I mean, there's some crazy stuff happening. I mean, you see some of the research out there. There's this. I heartily suggest you look up something called Chat Dev, which is a simulation of a software development organization, where you have the different roles in the software development organization, and you can feed ideas into, say, like product owners, and they'll actually produce working software, proof of concepts of working software at the other end, based on these multi-agent this multi-agent system. So as I say, it's open research at the moment, but we're seeing this as one example of one of these interesting architectural styles that's starting to bubble up. Yeah, back to you, Rachel.
Yeah, it's a very interesting space, and I'm glad you gave us a bit of a breakdown of some of the many different types of agents that are out there. It's a little terrifying to me when I hear about, agents building software. I know right now it's, great coding assistants out there. They're getting better and better, but the code generation part of it, I'm much more skeptical about, because obviously at Thoughtworks, we're big into, the total cost of ownership of the software long term, not just how quickly can you build it. So it's going to be very interesting to see how this space evolves. But getting a bit more deep. Sorry, do you want to say something else, James?
No, yeah, no, I just agree. And there's all the usual caveats that apply, Rachel, right? So, just because we call them agents doesn't mean that they're not hallucinating like all these other, like every other form of LLM is doing. So, you really need to make sure that there are humans in the loop when you've got anything autonomous doing autonomous things, when they've got the ability to just completely make stuff up. So,
Yeah, well, yes, and as an industry, we're known for being, very, very good at focusing on maintainability versus just being able to get things done as quickly as possible. So that's why I guess I have the skepticism and concern about, the proliferation of these things and the guardrails, to the point Tanya made earlier, that we need to start bringing in and putting more attention on. Tanya, did you want to add something?
Oh yeah, it's just so this is an assess, so just always, anything that we are finding interesting, but not necessarily production ready, right, is what we are putting here. I think the autonomous nature of these agents is both what makes it interesting and also scary and unpredictable. So that's very much why this has been on the radar a few times, but still in assess, because we still have these concerns over how well they actually work, in a proper production ready system. But we are also seeing some evolution in how people are building these things. So Crew AI and AutoGen, which James mentioned earlier, we actually blipped them in the previous volume. In the current volume, LangGraph also came to our radar, which is another way that you can build these things, but it takes a different model where it generally tries to give more control over the flow of the program to the author as compared to the Crew AI and AutoGen, which is a bit more autonomous. Yeah, so I think, again, the autonomous bit is both what is exciting and scary, but it is definitely an area that we think is worth keeping an eye on.
Yeah, I predict a big shift in our industry over the next few years as we see the long-term effects of these things. And it won't surprise anyone to know who's listening on the webinar that this was hotly debated as to whether it should actually move into trial, because we do actually have production experience with these kinds of things. But we felt that assess was a good place for it because there's still a lot to be determined, and I think that's clear from the conversation. So let's keep going, otherwise we won't give anyone any time to ask questions at the end, and dive a little deeper into the framework space. And Tanya's going to tell us a little bit about DSPy.
Yeah, so DSPy is an assess. So this is a framework that takes quite a different approach to building LLM or language model based systems. So if you've done one of these before, a lot of it relies on prompt templates and sort of prompt engineering by hand. This one takes a different approach, much like I can't say that I'm an ML expert, but this takes an approach much like training neural networks, so it's something like PyTorch. And in fact, I think there's a paper that comes with this as well that came from the authors of this, and it did mention that PyTorch is one of the inspiration for that. So it takes a different approach, as in instead of handcrafting your prompts and prompt templates, you give it kind of what you want to do. So sort of, for example, you want a chain of thought thing, or you want a dynamic, you want a few shot thing, and you give it some data to train with, you give it some metrics to optimize for, and then you compile it, and with the compilation process, it will either update the prompts or generate the prompts, again optimizing to the metric that you're giving, or it might also update the weights of the model that you're working on, and then it spits out the optimal thing that it finds, right? So that's why it's kind of an interesting thing. The analogy that the authors are making for this, which, by the way, this came from the Stanford NLP group. The analogy that they are making for this is that so far with prompt engineering by hand is akin to people tuning neural network weights by hand, whereas something like this gives you the higher level abstraction of training the neural networks without tuning those weights by hand. So it's an interesting approach that a lot of our engineers, a lot of our technologists find exciting. They're playing with this, haven't quite gone to production yet, and that's why it's still an assess. But yeah, I think we are very excited to see where this might lead. Part of the premise for this too is when you're starting to build more complex systems with language models, right? If you change one prompt here, it might then kind of affect something further down the line, and you have to tweak multiple of these prompts. But with this, you can it's less brittle is kind of the premise, right? Is that you can optimize things at a higher level, and the prompt itself, you don't necessarily sweat over the details of it. In terms of performance, as part of their paper, they did some analysis comparing the prompts that this generates versus expert created handcrafted prompts, and it seems to be performing comparable or actually beyond what those handcrafted prompts are able to do. So yeah, so that's why we think this is an interesting one to experiment with, to play with, and let's see where this goes. It might lead into a different way or this sort of way of building applications with LLMs. with language models, but yeah, we'll see.
It is interesting because I feel like a year ago, everyone was telling us that we weren't going to be software engineers anymore. We were going to be prompt engineers, and already there's, abstractions coming into the loop. Do you think there's any noticeable downsides yet with using this? You mentioned performance, but I know it's early, any noticeable downsides with using this type of tech?
I don't know about very clear downsides yet, but it's certainly a different way of thinking, because I think from the time that language models came into the forefront in the popular, discourse, people are so used to prompt engineering and prompt templates, and people have been thinking about, oh, I need to do one shot or few shot, or I need to do this and that. And it's quite a shift to even try to do it differently with this. So I think I don't know if that's a downside, but there's certainly a bit of a learning curve, right? And the question is, is that learning curve worth it? Is the juice worth the squeeze? Is it going to result in really a less brittle set of applications or not? So I think that's a question. But in terms of downside, apart from the learning curve, I don't know what it is just yet.
Yeah, too early to say. Okay, well, we're not done with LLMs yet, but I do promise we will talk about things other than that. I'm going to hand over to James now to talk about function calling with LLMs.
Yeah, thanks, Rachel. I mean, to give you a bit of an insight into what was happening in the room, this was probably one of the things that caused the most discussion, function calling with LLMs, or LLMs being able to invoke functions. What does that actually mean? We went around the houses trying to work this out. Because there's, again, much like the autonomous agents, there's many different ways you can look at what a function is, how a function is called, etc., etc. So I'm going to talk a bit about the sort of, I guess, accepted version of this, which is essentially the ability for as part of prompting an LLM to be able to define in context a set of external functions that can be called by the model in order to provide additional information to the answer. Because of course, if you think about when training occurs for these things, it's obviously lagging real life, right? So whatever we're asking ChatGPT at the moment, the current version, it was trained on data that stopped at a certain point in the past. So whilst I might be able to say, can you give me the historic weather patterns for the city of San Francisco in the 1950s? You can't say, can you give me what the weather was like today in San Francisco, without it having additional information or the ability to find additional information for you. And that's really what the function calling thing is about. So being able to sort of provide a set of external resources that these models are able to use to provide more up-to-date, I guess, information. That would be one example of it. So, for example, weather lookup in a city would be a good example. Also, things like using maths libraries. I know there's a lot of work at the moment being done on actually doing maths within the models, within the LLMs, but actually being able to access external maths libraries is another good example. Or, for example, things like, I don't know, you might want to do things like call out to a customer database or an order management system if it's a chatbot to get up-to-date information on the current state of a customer's order. So being able to take these tools and provide a mechanism for them to call externally seems to be pretty interesting. Well, it's working. So, and we first had it in trial. This volume. Model. I'm saying model so many times I can't stop saying it now. It's a bit annoying. So it's first appearing this time. I suspect this will be something that will appear again and again and again as more frameworks appear in order to make this more usable and interesting. So there are some caveats with this as well, because you can do things like combine this with agents and make the agents able to access external sources of information as well. But then I started to think, and maybe this is just me, what about things like idempotency? What about things like side effects? What about things like allowing agents to be able to actually not just interact and read from the real world, but are able to write into the real world as well? So sending emails for you, creating calendar invites. These are all side effects, essentially, that you can also imagine being used with external function calling. The other fun thing is that using my understanding based on the work of the great Eric Meyer, who's obviously ex-Microsoft, ex-Meta, and he's now got his own thing going. He's working on how you can create programming languages to allow what he's talking about is what he calls neural computation. And so using things like the React, not the JavaScript React framework, but the reason action type framework, how can you stop those frameworks from, or that pattern from allowing the answers to the external function calls to be ignored essentially by the model? Because there's a real issue that if the external information doesn't fit with what the model thinks should be coming next, it can just ignore it and hallucinate something else. So he's working on some really interesting tooling around introducing semantics and actually forcing semantic reasoning into the interactions with these external functions, which is fascinating. So yeah, it's at the forefront of current research. So we've been doing it internally. We've been using these sorts of tools internally and with our clients, hence it's in trial. But it's absolutely just at the cutting edge, and I guess we'll see what happens next.
So James, you mentioned it was one that we went round the houses on and we discussed at length. What was some of the controversial tidbits you might want to share with the group?
I mean, without showing too many, without showing too much of the internal workings, I don't want to break encapsulation here, to be honest, Rachel, right? But too much, because that's not a very low or microservices thing to do. So, we want to encapsulate what's going on within that group. But I mean, are we talking about the creation of functions as in, is it like where you're using a copilot and it's suggesting functions that you might want to include in your code? Or is it creating functions and being able to externally call those functions to get information? So those are some of the conversations that we went around the houses in. How do you disambiguate between the two things and so on? So yeah, go on. I tell you, it's a pretty intense week.
It is a lot of fun though, and I saw in the chat that some people talk about doing their own radars. It's a pretty common practice now. We help our clients facilitate, and we teach them how we do it, and then they adapt it for their own purposes so that they can look at ways to adopt new tools and techniques and frameworks. It's kind of out with the old school architectural review board and in with something that's a bit more dynamic and movable and changeable. And if you hadn't already guessed from James's comments, he wrote the canonical article on microservices way back. Are we at 10 years now? James, it's 10 years since the introduction of microservices, or at least it became, a thing. All right, so we're going to move on from LLMs, believe it or not. As Tanya said, 38% of the radar is made up of generative AI things, but there are other things on it. And obviously we care deeply about developers. We've been big proponents of developer experience and making productive working environments for developers. But local dev environments is always a continued challenge, which is surprising to me, but it seems like what old is new again and no problem ever really gets solved. So Tanya, tell us about DevBox.
Yeah. So like Rachel said, this is very much a back to basics sort of blip because this is about setting up portable and reproducible development environments. Before we get into what this is, some of you who have been following the radar for a while may actually realize this has been on the radar. It's going to be in the next edition as well, so it's going to be the third time that it's on the radar. So it was initially in assess, it made it to trial in the previous volume, and it's now there again in trial. Well,
that means we really like it for those at the audience at home.
Well, there is a reason that it made it to trial, and without breaking that encapsulation that James was mentioning too much, part of the reason is we were discussing how it's still a problem. This like setting up local development environments that are consistent among engineers within the same team. That makes onboarding painless and very quick, and that gets rid of that problem of like, oh, it works on my machine but doesn't work elsewhere. Like we've heard that for years, and it still is a problem in a lot of teams, right? So it's really that discussion that prompted, hey, we do have this thing that we just blipped the past two editions that our teams are liking, that are benefiting them in terms of streamlining that onboarding. Why don't we call attention to this again? This is certainly not the only solution to that problem, but it is one that, again, we've had some success with quite recently as well. All right, so that's a lot about what this is without telling you about what it is. So what DevBox is a command line tool that provides a pretty approachable interface for setting up local development environments. They are, as I said, portable and reproducible, and also isolated in the sense of you can install command line tools within the DevBox sort of environment that doesn't conflict with the other things that you're installing in your local machine. So isolate in that way. And so so you can imagine this goes beyond what language-specific package managers do, right? It doesn't install like Python libraries, but it installs, or it can help you set up like what Python version or what CLI tool, like a specific version of some other CLI tool, so that experience is consistent for everybody. I guess one other thing to note about this is it uses Nix under the hood. I think specifically the Nix package manager. The Nix language itself has, I can't say personally if it's warranted or unwarranted, but it has a reputation for being a little hard to learn, like having a steep learning curve. DevBox uses the Nix package manager, so it when you specify what packages you want to install, it uses the Nix package repository, and then it installs it using the package manager locally. But then it creates a shell environment when you do DevBox shell. So when you enter into a shell environment that you create for a particular project or DevBox, it then creates sort of an environment that symlinks with that creates symlinks to those packages that are installed through the Nix package manager. So again, with that, it creates this isolated environment that doesn't conflict with the other things that you have going on in your local machine. And yeah, so we have it has some other things too, like you can there are some like hooks you can put into it so that certain scripts are run when you enter the environment or when you exit the environment. And it has some ability to kind of work with VS Code or some other IDs as well through the devcontainer.json spec. Yeah, so again, some of our teams are using this and they are finding it fairly easy to use, and it solves the problem for them of this like inconsistency of environments between engineers within the same team. So we think it's worth calling out that this exists, and that if you have this problem, this is one of the things that you can try to use in your project that we have had quite a bit of success with so far.
Great. Well, as you say, like it's a problem that's been going on for a long time. I remember probably 15 years ago having that problem of it works on my machine, and I guess it's not surprising that it's not quite solved, and we're still introducing tools to solve that. But speaking of things that continue to be a problem, integration tests have always been very challenging and brittle in my experience, which is why we've been big proponents of unit testing and TDD for forever, basically, as Thoughtworks. And so this is one of the areas that we've put on hold, as like proceed with caution. And I'll hand over to James now. I'll just warn James, we only have 20 minutes and we've still got a few things to go through. So please don't rant too much. No, I'm just kidding. But do tell us, like, remind us, what is the problem with the enterprise-wide integration test environments? I mean, I personally remember sitting for hours and hours and hours dealing with brittle tests, but yeah, tell us, why is this still a problem?
Yeah, it's and I mean, you know me so well, Rachel, to try to stop you from rambling. I could do this. I could probably talk about this for the entire hour, but I won't. And I'd actually go further than say proceed with caution, and I'd say avoid these. In fact, I'd go for the strong version of our advice in the hold ring. So what do we mean when we say enterprise-wide integration test environments? We mean that kind of environment where consistently over the years. You have the one environment that many teams have to fan into in order to integrate and run integration tests with other teams' software, other versions of teams' software. And the reason we find it still is a problem, many organizations still have these, like a single environment where you have to run integration tests, either on-prem or even or in the cloud still. And this is another one of my bugbears, which is the whole distributed monolith microservice anti-pattern, if you like, which is where you don't have these independently deployable services or independently deployable pieces of software, and you have to test them with everything else all at once. So often the reason we see this is because, well, sometimes it's because it's too expensive to get another one, right? You've got big bits of kit, so like, oh, we can't possibly afford another license for insert big enterprise software package name here. So we just have one of them, and we'll have to all integrate and test it on that one thing. It's often because there's lots of these things, lots of boxes or lots of bits of software, and it's really hard to unpick it all. If you've built up a legacy environment over time, if you've got one of these big old things that's been around for 10 years. And the problem I see, and this is, I was given an example before the webinar started of, being asking a sort of a hands in the air thing at a conference I was at recently. And probably, I don't know, a quarter to a third of the attendees at my talk also said they were having problems with deploying into single enterprise-wide integration test environments. What are the problems? Well, the problems are essentially failure demand, right? They massively increase failure demand. They reduce your ability to get stuff done, right? So you have to wait on other teams and their versions before you can test with them. So that's like a waiting, like synchronization problem. You have a bunch of queues in there, so often you have to wait, for your turn to get into the integration test environment because it's scheduled at some point in the future. And then again, there's related to that, there's the cadence. How often are you allowed to test in the integration test environment? And a lot of these things, they tend to lead to things like release trains. They tend to lead to a lack of ability to do continuous deployment. So that's why we sort of say avoid, and that's why we're still shouting at clouds like the Homer Simpson thing. What can you do instead? It's all very well for us to say, well, don't do this, without saying do something else. And I guess the things we should be thinking about doing instead is focusing on independent deployability of the components or services using techniques that we've had before, like consumer-driven contracts to isolate ourselves from our dependencies, using patterns like canary releasing or feature toggles and blue-green deploys to decouple deployment from release. And then using a lot of the things that we've sort of evolved over the last decade, testing in production, things like using synthetic transactions, all these sorts of techniques. So yeah, it's still a problem. That's why we're calling it out again. It's stuff we see too much, and we wish we didn't see when we're out consulting. So back to you, Rachel.
Well, thank you for keeping that short and sweet, James. I personally could also spend probably an hour or two talking about why this is a problem and what the alternatives are. And somebody made me laugh earlier. They put in the chat, mock loudly with 2 exclamation points. But I'm going to move back to now developer platforms again with Tanya, who's going to talk about SCORE, which I believe is a platform orchestration language. So why does SCORE exist? What does it do?
So what we quite commonly see is that what engineers have in mind when they want to run an application, in particular as a containerized workload as it relates to SCORE, is different to how platform engineers think about running those containerized workloads. So platform engineers will think about more things, more policies that need to be implemented across the enterprise, across the organization, and so on. Whereas the application developer is just thinking, well, I just want to I want this base image. I want to open this port. I want that port. I need a database. I need this particular database, and I need that to talk to that to be able to talk to my application and things like that. So it's a bit more simplistic or straightforward, right? The way that application developers think about what things I or my application needs out of the platform. And so why does SCORE exist? Well, let me talk a little bit about what SCORE is. SCORE is a spec coming out of Humanitech, actually, but that they recently transferred the custodianship off to the CNCF umbrella. I think that happened pretty recently, so maybe in July this year. What it does is it basically gives an abstraction, that spec is like an abstraction for the platform capabilities, but that is oriented towards the interest or the focus area or the scope of an application developer. So it allows application developers to specify, well, here's the things that I said earlier. Oh, I want this base image, I want this port, I want this script to run. And then from there, it can be translated into a Docker Compose YAML, or it can be translated into a Kubernetes, into a set of Kubernetes objects and so on. And that's to some degree in the control of the platform team, while keeping that simpler interface for application developers. The reason that this made it to the radar at all, and also part of the reason that I'm bringing it up here, is in our discussions, we talk about platforms as a product so much, as well, like volume after volume. Some version of it always comes into the discussion. And part of that, part of implementing platform as a product that we often see in organizations is platform teams creating a language like this to make things simpler for application developers, right? So that the platform team can implement all the policies that make sense broadly, but they can keep things simple. So the premise of SCORE is to be that spec that can be less, snowflakey, that's different from organization A to organization B. That still needs to be, we still need to see that happen, because this is, again, something that came out of Humanitech and just got donated, but we're watching it with interest because we think it has that, at least with the change of custodianship, we think there is some future potential of this becoming a larger standard within the community to eliminate the snowflake or the many different versions of something like this in different organizations. But yeah, we still need to see that happen, but we're watching this with interest.
Yeah, I mean, I hope it gets uptick, because I know that we all love meta work and rolling our own frameworks and languages, but it certainly makes maintainability and total cost of ownership easier if we use things that are more standardized. So yes, it'll be interesting to see how this develops. So we're gonna pop back to Gen AI now, and something talking about total cost of ownership and maintainability of systems, and the fact that most of us are actually not in a greenfield environment, and most of us are challenged with the brownfield of code either we wrote ourselves and we no longer remember, or somebody else wrote, and how you can use Gen AI to actually understand legacy code bases. James.
Yeah, so I'm going to just briefly give an example of this, because as I say, we're coming up to the top of the hour. So I'll pose the question, which is, I was at a client, and they were talking about the problem that they had with a 50-year-old mainframe which had over 250 million lines of code in it, right? So, and they're talking about modernization. They're talking about how do we sort of make sense of this when actually a lot of the people who were involved in writing this over those 50 years are no longer around. They're not working for us anymore, for example, or have retired. I mean, that's the sort of, I guess, degenerate example or reductio ad absurdum of the case, 250 million lines of COBOL. But but it does beg the question: how do you actually how do you tackle some of these problems when you've got legacy code bases? And there's a bunch of I think approaches starting to be taken now using Gen AI. So there are tools out there, for example, like Bloop, and there's Driver AI. They do slightly different things. So Bloop is a research project which will do things like convert COBOL into Java for you. But it'll also allow you to will help you write COBOL and understand COBOL COBOL code bases. Driver AI, my understanding is it's much more about how we can bring this essentially all of the documentation, all the kind of all the content that surrounds your code base, and actually be able to query that and make sense of that using a chat-based interface kind of thing. So those are kind of interesting tools. They tend to use a retrieval augmented generation in order to sort of provide additional context then to the models. Now, the reason I wanted to bring this up is because we've been having some. I mean, this is close to my heart. I've been writing some patterns on Martin Fowler's website called the patterns of legacy displacement. And one of the things we see consistently is around how do you understand these big systems so you can break them up and break them up incrementally. How do you find the seams within these systems? And we've been quite successful now. We've got some pretty good existence proofs internally of a tool called Code Concise, which is allowing us which is getting some traction to allow us to do that. So I guess I can't go into too much the architecture. There's a big article on Martin Fowler's site about this if you're more interested. But essentially, it uses a set of adapters for different languages that allows you to sort of import essentially the AST of the language, or using the AST of the language, import a code base into a graph database. We're using Neo, I believe. And then be able to sort of augment that graph as part of the retrieval in the RAG, to be able to essentially ask questions of these giant code bases. Obviously, I can't go into, this is touching the surface of it here. But it's interesting because you can ask about specific parts of the code, specific things like fields and how they how they use throughout the code base or whatever. But from my perspective, we've had some interesting breakthroughs in how you can look at the large-scale structure, the semantics, the business semantics of these code bases. Can you build me a capability map? Business capability map of this giant code base. And if you can do that, you can start to do things like trying to identify these seams, which pieces of these are cohesive around the business concerns that we might want to go after if we're doing a legacy modernization or looking to split these things up. So it's an interesting space. It's really at the forefront again of what we're doing, both in Thoughtworks, but I guess in general. But is a specific use case of using some of this tooling and these new architectural styles together to actually solve real world problems that we see as engineers, right? That we see as developers.
Yeah, I mean, again, this is another topic that we could dedicate many hours to because I'm fascinated by it. And prior to doing this role, I used to run our enterprise modernization platforms and cloud service line globally. So I'm really fascinated to see how the tools develop. There's been tools that in theory understand and translate old code bases into new for years, but I don't think anyone jumps from the houses and says these are amazing. So it'll be interesting to see how Gen AI can and other tools can change the game on that and help us understand and interrogate those old code bases. All right, we're running out of time. And we want to be able to have a few minutes for questions at the end. So hopefully we can go through this one quickly. Tanya, speaking about what is old is new again. Observability, that's not a new thing. What's Observability 2.0?
Ooh, no pressure talking about this in a few minutes that we have left. What's new? Well, how about we talk about what's old first, or what's 1.0 first? A lot of us, the way that we think about observability today is metrics, traces, and logs. And a lot of the tooling for observability today are oriented around those concepts. Observability 2.0 is this approach or paradigm that is being floated around by charity makers of Honeycomb for the most part, and some other people that relies on sort of a unified way of looking at these signals. So rather than metrics, traces, and logs, but treating logs as events and not just a text that you put into it, right? So this is definitely a little bit of a what's old is new again, because if you think about the techniques that go into it, like structured logging, that's not new. It's been there for years, and we've instrumented. I think a lot of us have instrumented our logs with some key value things, right, to make it richer than just logs, to make it events. But this is kind of taking that idea and making it the main component of observability. The thinking there is the thinking there is that it gives you a really rich, data set, really rich telemetry on how your application is running, and especially if you instrument it with your trace and span IDs as well, and if you use this other technique that is called canonical log lines, also not very new. There's a blog post from Stripe as of like 5 years ago. But if you use structured logging with in combination with these techniques, the idea is that you're going to have rich telemetry about your application that allows you to ask questions about the data that you don't have to think of beforehand. Whereas with metrics, traces, and logs, these are disparate things, and like metrics generally are fairly aggregated. Like, they make sense for aggregated questions, right? Like, okay, what's my error rate within this particular period, but then you have to correlate it with like what am I seeing in the logs? So with this, the idea is you have a rich telemetry that's unified. You can ask it many questions that you generally can't possibly think all about in advance. But the caveat here is, and this is again also partially why it's an assess, is it's not really a small shift. A lot of the tooling today still relies on that paradigm of metrics, traces, and logs. Their cost model as well. So if you were to do this, there are only a handful of options, I believe, right, that really supports this model. You can go with a do-it-yourself approach as well, essentially like putting the logs into a data warehouse for your engineers to be able to query them, any sort of columnar data warehouse. But it is still not a small shift. So it's still assessed because it's an interesting alternative model with the premise of, again, being able to collect data that then allows engineers to ask many questions that they can't think of before, but with the cost of that shift being not really trivial.
Yeah, it's really interesting. And probably worth trying out on a few applications to see whether the cost is worth the transformation cost is worth it. So I didn't leave a lot of time for questions, but thankfully you have all been answering them as we go. There is one question, Tanya, about DevBox, about what have our teams been hearing about the time and maintenance cost of keeping up-to-date images for the team, and also any comments about the costs from other major providers?
In terms of the time and cost to maintain and keeping up the up-to-date images for the team, I don't hear much about it. It's mainly, I don't think it's much different to keeping the versions of your dependent libraries up to date as well. There's certainly some cost to that, but not too different day to day. The question about any license comments about the cost from major providers, I'm not sure what to make of that. I suspect this may be related to DevBox is not a very unique name. I think somebody posted on chat that Microsoft has a thing called DevBox as well. What I'm referring to is the Jetify DevBox, which is an open source thing, and the things that you can install in your isolated environment that you created with DevBox are mostly things that are in the Nix package manager, which are mostly open source things. So nothing specific that I can comment on related to license and cost from major providers.
All right, well, we've hit time. So that was a lot of fun. Thank you, James and Tanya, for sharing your insights. I feel like most of those topics could have been their own hour, but I appreciate your time, and thank you everybody for joining. And just a reminder, we are releasing this on October 23rd, so you can see everything else that's on there. There's about probably 100 plus blips. Thank you, everyone.
Thank you, everyone.
Bye-bye, and thanks.